Hello everybody, this lesson is on factoring. Specifically, we're going to look at how to factor out a common factor, how to factor by grouping, and how to factor using difference of squares. First, we're going to start with grouping and common factor. Now, taking out a common factor, I actually have a separate video lesson on how to remove a common factor in more detail, which I'll link in this video right now. But it is important for you to know how to remove a common factor if you want to do something called factor by grouping. We factor by grouping when we have a polynomial that has 4 terms, or in these examples anyways, they will have 4 terms. So I'm going to do some side-by-side examples at the same time. So you'll notice that I've given you 2 polynomials with 4 terms in it. And we are going to do something called factor by grouping. Factoring by grouping just means we are going to factor by grouping our polynomial into binomials. I'm going to factor by taking out the common factor of the first 2 terms and then taking out a common factor of the last 2 terms for both of these examples. Before you decide that you do want to take out a common factor by grouping certain terms, you do need to make sure that your polynomial has groups that have a common factor. It's possible that you might get a polynomial with 4 terms that are not in the right order, and so you have to kind of reorder them to make sure that the first 2 terms have a common factor and the last 2 terms have a common factor. However, in this case, I do have 2 first terms with a common factor, 2 last terms with a common factor, 2 first terms with a common factor, and 2 last terms with a common factor, so I don't have to rearrange anything here. What this looks like is if I take out my a, I'm left with the remainder x plus y, and if I take out my b, I am left with the remainder x plus y. And in this case, between the 6 and the negative 15 terms, I have a 3x squared as my GCF, or my common factor, and then dividing both of these by the 3x squared, I'm left with 2x minus 5. And then between the negative 8x and the 20, I take the sign of the first coefficient, which is a negative, and I take out a 4 between the 8 and the 20. I divide both the negative 8x and the 20 by the common factor negative 4 to give me 2x minus 5. And so right now you'll notice that I have brackets in both of my examples that are identical, and that's what we want. We want, when we're factoring by grouping, our goal is to get a remainder, we'll call this the remainder, brackets that are identical within the first and the second part of the polynomial. After that, once you've removed the common factor, all you have to do now is combine the remaining terms. So in this case, my remaining terms would be like a and b, and they form their own bracket. And then my x plus y, which was identical, I just kind of hook onto the a plus b. It doesn't matter the order that I put these brackets in. I could have put my a plus b first and my x plus y second. In my second example, I'm left with 3x squared minus 4. So 3x squared minus 4 is actually going to just be its own bracket side by side with the identical bracket, which was 2x minus 5. Again, it doesn't matter the order in which you put these brackets in. I could have put my 3x minus 4 first and my 2x minus 5 second, but you are still left with, again, when you factor by grouping, you are left with 2 brackets side by side. And of course, if you wanted to check your work, you would just have to multiply these out and you should get what you started with. Here are some questions that I would like you to try on your own. I encourage you to pause this video and continue for the next slide for the answers. For the first one, I've already removed the common factor for you. I've already removed the common factor 5c and 2d, and I've already given you the identical brackets r minus s. So all you had to do for this first example is create a new bracket with 5c and 2d, because these were the remaining terms, and then hook on the r minus s bracket to it. The second example was the same thing. I already removed a common factor of a in the first part and negative d in the second part. So all that's left for you is to grab this identical bracket, b minus c, and beside it or in front of it, you're going to put a minus d with it, because a and negative d were the remaining terms. Question 3 was pretty much the same example I gave you in first. I'm going to remove the a to get x minus y, remove the negative b to get x minus y, and then I get a x minus y, and then negative b x minus y. And so I have my identical bracket, which is x minus y, and I hook it on with a minus b because these were the remaining terms. In my fourth example, and I haven't said this before, but always check to see that you do have a common factor between the first 2 and the last 2 terms. In the first 2 terms, my common factor is actually going to be an x squared, and my last 2 terms, my common factor is going to be a 1. And I'm sure you're wondering to yourself, like, oh, do I have to take it out if the common factor is 1? For the purpose of Taking out a common factor by grouping, you do have to remove the 1 and divide both by 1. This is what happens. I have x squared is my common factor between my x cubed and my x squared, so I'm left with x plus 1. I take out 1 because my common factor between x plus 1 is 1, and I'm left with x plus 1 again. I have an identical bracket, x plus 1. I'm going to put that here, and I'm left with x squared plus 1, and I'm going to add that in the second bracket together with x plus 1. Finally, in my last example, I do have some common factors going on between the 4x squared and the negative 2y cubed, and I do have some common factors between the xy squared and the negative 8yx. Just be careful. Some people always ask, does this matter? It doesn't matter. xy, yx, it doesn't matter. So what I've done here is I've actually swapped the negative 8yx and the negative 2y cubed in order to make sure that when I do remove a common factor between the first two terms, I get an identical bracket that is the same or identical as the last two ones when I remove their common factor. Here's what happens. I have 4x squared minus 8yx. I remove a 4x. I'm left with x minus 2y after dividing. And in the last two terms, after I've rearranged it, I've removed a y squared, and I am left with, after dividing, x minus 2y. So I'm happy because I have an x minus 2y identical bracket, and then I'm left with 4x plus y squared, and that becomes its own bracket. Now let's talk about difference of squares. First, you need to understand what exactly a difference of squares is, and the key word here is the word difference. So we're looking for a minus sign or a subtraction sign, and what you are minusing or subtracting is two terms that can be perfectly square rooted without any decimals or any leftovers, basically. What you need to understand is when you're dealing with difference of squares or perfect squares, a perfect square with a variable is an exponent that is even. You cannot have a perfect square with an exponent on a variable that is odd. And then if we're talking about constant numbers, the constant numbers must be a square. So a number that can be perfectly square rooted. You should by now know some of these to be something like 4, 16, 81, 36. These are all numbers that if I were to, square root, I would know the answer of at this point. So in this case, I have two examples, y squared minus 16 and 9x squared minus 36. And what you're going to do with when we talk about difference of squares, first you have to check that they're being subtracted, which they are. Then you do have to check always if there is a common factor. If there is a common factor, take it out. Even if it's still a perfect square, it's just going to make your lives a little bit easier. For the y squared minus 16, there is no common factor, but for the 9x squared minus 36, there is a common factor of 9, which I'm going to remove and divide both terms by to get x squared minus 4 as my remainder. Step 2, ensure the first and last term are perfect squares, which they are, and it is a difference, which they are, and then make two brackets. So for the first example, there was no common factor, so I'm just going to put two brackets here. And for the second example, I'm just going to remember to put the 9 that I removed and the two brackets after that. Step 3 is to square root each term. So if you do the square root of y squared, you get y and y. If you do the square root of 16, you get 4 and 4. Here, if you do the square root of x squared, you get x and x. And if you get the square root of 4, you get 2 and 2. Or 2, just 2. But I do have to put them both in the same bracket. And then the last step is you're just going to make that one bracket is being added and one bracket is going to be subtracted. And again, you have 9, x plus 2, x minus 2. Of course, if you wanted to check your work, all you would have to do is multiply this out and you would get the difference of squares that you started with before you factored them out. Here are 6 examples. I encourage you to pause this video and try them on your own, and then continue the video to see the solutions. In my first example, I have a beautiful difference of squares with no common factor, but I do have to square root both of the terms. Square root in the first term gives me 2t, so I write 2t in both brackets. Square root in the second term gives me 3s. I get 3s in both brackets, and I can't forget to put a plus and a minus in between each of these. In my second example, I don't have a common factor, so I don't have to take anything out. I just have to square root them. The square root of 16r squared is 4r, and the square root of 25y squared is 5y, and then I put a plus and a minus in between them in each bracket. In the third example, I do have a common factor. My common factor is 25. If I divide 25 to both terms, I'm left with m squared minus 16. And so then I'm going to square root m squared minus 16, and that is going to give me m and 4. I'm going to put m and 4 in both brackets, and I'm going to put a plus and a minus in between them, not forgetting that I have to stick my common factor in the front. For question number 4, I don't have a common factor, but I do have a difference of squares. So I have the square root of 64a squared is 8a, and the square root of b squared is b. So I'm going to write 8a and b in both brackets with a plus and a minus. For question number 5, I do have to remove a common factor, especially because I see that I cannot root an odd exponent. So I'm going to take out an a. When I take out an a, I am left with a squared minus 4. A squared minus 4 is a difference of squares that when I square root, I get a and 2. And so I put a and 2 in both brackets, and I put a plus and a minus in between them. And in my last example, I do have a perfect square of 1 minus 16a to the 4. I square root the 1, I get 1. I square root the 16, I get 4a squared. But notice what happens. I write 1 4a squared in both brackets, and I put a plus and a minus in between them. But watch out, because what I've done is I've actually created a perfect square, or a difference of squares with my difference of squares. So in this case here, I do have to still expand this out a little bit further, because I can square root 1 and I can square root 4a squared, and it is a difference. So now I am left with another difference of squares, which is 1 and 2a with a plus and a minus in between each of these brackets. Here are some more questions that I would encourage you to try on your own in terms of just factoring out a common factor, factoring out by grouping, difference of squares. I encourage you to pause this video, try them on your own, and continue on the next slide for the solutions. So all I've done here is I've just given out the solutions for you, and I'm just going to go over what needed to be done in terms of what type of factoring it was. For question number 1, you just had to take out a common factor, which was 5xy. For question number 2, you did have to factor by grouping, and in this case, all of the terms are in the right order, so you don't have to rearrange anything. So you are left with a y squared minus 2 as an identical bracket with x minus 7. As your leftovers. In the third example, you do have a difference of squares. You're going to square root the first term, which is going to get you x squared, y squared, and you're going to square root the 16, which is going to give you 4. But again, you need to watch out, because the second bracket that I have newly created is its own difference of squares, which I will have to square root and create 2 brackets for, which will become xy plus 2 and xy minus 2. In question number 4, you do have to be careful, because while the first 2 are squares, they are not difference of squares because it's a plus. So I just wanted to be sure that you saw this, because teachers might trick you. So in the end, there's actually nothing you can do to factor this. It's just left as x squared, y squared plus 100. Which is the original question that was given to you. For question number 5, what's actually happened here is that you have been given a common factored bracket, if you will, which was your y minus 4. But if we look at the 3x squared, the 6x, and the negative 9 that are left, you actually could remove a common factor from those 3, which is a 3, which is why I've put a 3 out here. So you're actually left with remainders or leftovers as x squared, 2x, and negative 3. So what I've done is I've hooked the 3 common factor on the outside. I grabbed the identical bracket y minus 4 and put it beside it. And then in this trinomial, I have x squared, 2x, and negative 3, because those are what was left over. And finally, for question number 6, there was a common factor between these 2 terms, which was 2x. If I divide both terms by 2x, I get 25x squared minus 1, which just so happens to be a beautiful difference of squares. So I'm going to square root my 25x squared to give me 5x. I'm going to square root my 1 to give me 1. I'm going to put them each in its own bracket. In between both of them, I'm going to put a plus and a minus. That is the end on factoring by common factor, factor by grouping, and factor by difference of squares. Thank you for listening.